Okay, this video is the day 8 solutions. I was asked to do 1, 4, and 9, or 1, 4, and 5, and I will be doing those, actually just 1 and 4. So the first one, we have an investment. It's compounded quarterly, so we're going to use the equation A is equal to P times 1 plus R divided by N raised to the NT. And we are asked to find how long it takes for it to triple in value. So what I'd like you to do is list all of the variables, list what you know, see what you don't know, and then substitute in and solve. Okay, so the ending amount, well, the principal we started with, we're at 3,200. And how long does it take for it to triple in value? Well, we need to take 3,200, multiply it by 3. So that's going to be $9,600. That's the ending amount. The interest rate is given as 4.5%, so 0.045. And number of compoundings, it is compounded quarterly, so that would be 4 compoundings per year. And we're asked to find how long. So we're just going to take that ending amount of 9,600 equals the beginning or principal amount of 3,200 times 1 plus 0.045, the interest rate, divided by my 4, the number of quartings, and raise that to the n times t, so it's going to be 4 times t. All right, so if I divide both sides by 3,200, that's going to give me 3 equals, take 0.045 divided by 4, add it to 1, that gives me 1.01125, and that's raised to the 4t. Well, I can't solve for that, so I'm going to change this into logarithmic form. Base is this number, so log base of 1.01125. I'm taking the log of the number, so that's going to be 3, and the log will equal the exponent 4t. So I need to use the change of base formula here to come up with what that's equal to. So I'm going to have the log base 10, the common log of 3, divide that by the common log, log base 10 of 1.01125, and that's going to equal 4t. All right, so when you take that in your calculator, you're going to get that 4t is now equal to 98.2027, and dividing both sides by 4, I'm going to get approximately 24.6 years. All right. Next one that I was asked to do was the last one, number 4. And number 4 gives you an equation. So the equation is A of t, so the amount after a given time, is equal to 14 e to the negative 0.16 t. So without even reading the problem, they give me this formula. I'm looking at A equals P e to the RT, where my beginning amount is 14. My ending amount is what we're looking for over here. It's going to be a continuous compounding here, or this is actually not that. It's a population or a pollutant, amount of pollutant in a lake, and the rate and the amount of time. So the amount of this pollutant is T is the number of years, and that's what we're going to be asked to find, I believe. So we don't know. It asks how long. A is the beginning amount, and that is really all that we have in here. E is a constant. That's at 2.718. So they asked me, how long is it going to take for the pollutant to reach 7 parts per million? So it's only 2 unknowns here, so I'm just going to substitute that in. And before I take the log of both sides, because I want it in logarithmic form, because I've got an exponential with a variable, I'm going to divide both sides by 14, just like I did in every other problem. So that's going to give me 0.5 is equal to base e to the negative 0.16 t exponent. All right, now I'm going to change this to logarithmic form. Base is e. So the natural log of my number, 0.5, is equal to negative 16.16 rather, t. And if you're doing your calculator, the natural log of 0.5, you should get negative 0.6931, and that's equal to negative 0.16 t. So t is approximately 4.3 years. Well, I hope that helps you. That was the only two questions. Good luck. Talk to you later.